Hi guys, I'm Vojtěch, and today I'm here to answer the question, can you use AI in a real product? And yes, you can. Thank you for coming to my talk. I'm joking. We'll dive more deeper than that. But first, I'll want to introduce myself and my product before diving into the AI stuff, which will be the pricing problem, model selection, and then optimizing and some personal experiments we had on a project. So as I said, I'm Vojtěch. I'm a programmer and a designer, also a founder. These are some of the products I helped create. And I'm also an AI techie. I studied AI in school, and I've been doing AI ever since. It's a very interesting technology. And right now, I'm focused on building products, both in B2B and B2C as well, with my dear friend and co-founder, Daniel. Say hi to Daniel. He's in Thailand right now. He says hi. Cannot be here, unfortunately. And we're focusing on a product called Steer. And this is something that I want to show a few examples on, which is a product that solves the specific problem with quick and precise communication. This is a great example. Product Hunt. We launched on Product Hunt a week ago, and I had to write a lot of comments, answer a few questions, and react to people. And it can be, it requires high mental effort and a lot of time. So we wanted to somehow solve this with AI, because language models, they are great for language, right? And we created something that would work in instant DMs, basically, in Slack, Teams, business communication. And we also wanted something that would help us keep our professional image, because if you make typos, if you make grammar mistakes, it doesn't make you seem professional. So we created a small app, which is ready to fix instantly anything with a shortcut. I have just a very brief demo here. And yeah, basically you select any text in any app, and you just improve the writing or just quickly fix the grammar and spelling. It works in any app. I use it in Gmail, on LinkedIn, writing comments, writing messages, writing emails. You can write it in Twitter. Just so you know, so we're on the same page. And the great stuff about language models is they can even understand if you switch the words, if you make some changes. For example, this should be here and not higher. But if I just select it and I improve it, it works pretty nice. So that's Steer. That's what we're doing. And that's the first topic of our talk, is the pricing problem. Because this is a new era. AI has recurring non-negligible costs. Everybody knows that, because you have to pay for the GPUs, for the compute. How do you solve this? You have basically three options. The first one being one-time payments, the second one being the regular monthly subscription, and the third and emerging one is the bring your own key. And let's start with the one-time payment. And one-time payment usually worked for software apps, for macOS apps. You're used to this. You can pay for, I don't know, clean shot, and you can take screenshots. You pay $20 and no other fees. But since the app APIs are recurring, you have to make sure that the customer lifetime cost is lower than the price they pay. For example, if you price your app for $30, you must be sure that the customer will not use more than $30, because then you will be losing money. And how can you approach this if you don't know the lifetime cost? Because you don't know how long the user will use your app if you're just starting out. And you cannot answer this. So instead, you should focus on removing or diminishing the cost of the API. And there's two approaches. You could use local models and LPUs. I will get into the details of both of these, but I'm just pointing this out. There's this really nice graph. If you compare prices of GPT-4o, which is the standard, and with LPUs, you can see that for Llama, 70 billion parameter model, it's 10 times cheaper, and for Mixtral, it's 20 times cheaper. And if you factor this in, you can actually have a one-time payment software that uses some of these models, and even though it's recurring, still, even if the user will be using it for 10 years, the cost will be smaller than the price. So this is one alternative, or one option. Then the simplest one, and the one that Steer actually uses, is the monthly subscription, where you just need to make sure that the price is greater than the monthly cost. And there's only one drawback. People will tell you, Why should I pay for this? I already pay for ChatGPT, I already pay for Claude. And there's no good answer. If the product is good enough, they don't care. Some people do, but you're focused on the ones that will actually pay you. And people that complain that they pay for GPT are not the ones that will pay you, usually, from our experience. And the last one that tried to solve this problem of I already pay for something is the bring your own key. And the notion is that the people that pay for GPT or some bigger model, they bring their API key into your app. And the cost is offloaded to the users, which makes sense, but there is one giant problem, and it's the user experience, the cumbersome UX. I don't know if you've ever tried to actually do this, but you have to go to the OpenAI, create an account, paste your details, submit $5, verify your phone number to create an API key, and 10 steps to do just activation of an app. Can you imagine if non-technical person does this? For example, somebody in marketing doesn't even know what an API key is. So this is really tough to pull. I recommend to do this only if you have a techie audience, such as yourself, guys, because you know what an API key is, right? But the regular people, they don't. And you don't want to include 10 additional steps in onboarding. People will churn out. So that's why we've opted in for the monthly subscription. I think it's the simplest. And yeah, so to quickly wrap this up, it's always a compromise between your audience, your required capabilities of the model, which I will get into later. And my tip is, if you don't know, just start with monthly. It's the simplest thing you can do, and you will see. Which brings us to the model selection. Basically, you have two options, enterprise and open source. Enterprise, everybody knows enterprise. It's ChatGPT, Claude, Gemini, every other big company that makes their own models. And then you have open source. And open source gives you more freedom, but also more responsibilities. You can use an external API, which uses the language processing unit. You can self-host it. You can run it on cloud provider, or you can have a local model. The simplest one is, again, enterprise. Combine monthly with the enterprise model, you have the simplest possible architecture you can have. It's very capable, and from our experience, it's very hard to beat GPT-4 because of reinforcement learning with human feedback, which means they actually pay teams of people to go manually through chat transcriptions and rank responses and train the model on this. There are people that their full-time job is to give feedback on conversations. Can you imagine this? And they have teams of people, and you cannot beat this. They have so much money, they can outsource it to other countries, and it's so powerful because all the stuff that's not in the books, all the human notion, all the emotion, a little bit of the human stuff, it's only possible with the human feedback, at least for now. And so it's very hard to compete with this. So this makes enterprise a very great option, and as I said, it's easy to set up. It's the easiest to set up. But it's slow. It's slow for real-time tasks. It's not slow if you want to generate a website, for example, because people, they know they will wait for 2 minutes. They don't care. They just care about the result. But if you want something real-time, it's not a very good choice. And the last point is it's pricey, but it's getting cheaper and faster. A great point that my friend Adam had is that AI right now is as expensive as it will ever be. So it will only get cheaper and cheaper. So enterprise will be more and more available, I think. But now, the more and the important and the fun stuff is the LPU API. And I will actually show you a demo, which I think is cool as hell. So I have a prompt, tell me a story, just a simple one, just to give you the idea. Okay, you can look at this and see, okay, that's fast, right? No, you don't know what's fast. This is fast. Okay, so this is, I think, 18 times faster than ChatGPT. And it's because they don't use GPUs. They use LPUs, language processing units, which is a different architecture. To be honest, I'm not exactly sure how it works. They just solve the compute bandwidth problem. Don't ask me how. It's very cheap because it uses open source models. As I've already said, it's 10 times cheaper than GPT-4o. And for Mixtral, it's 20 times cheaper. And for small llama, it's 100 times cheaper. So if you want something that's not escapable but very cheap, this is the best choice. It's very fast. It's incredibly fast. Yeah, we had the demo already. Then this option of self-hosting is something that we don't have much experience with, but I just wanted to include it for the sake of being complete. And you can host your own models, or usually you take some open source model like Llama or Mistral, and you train it, and then you host it somewhere because you need to call an API. You have to basically build this API. Where do you host it? You can host it on Model AI or on AWS. Model AI is very expensive. They have this pricing here. They charge you per second of computing on the GPUs. And 1 minute of 60 tokens per second, which is average of the Mistral open source model, will cost you $7, which is an insane amount of money. And basically all they do is they host it on AWS, and they just give you the developer experience, and they charge a big margin for it, right? So, but of course it's more convenient. That's why people pay for this. If you want to avoid this, you can host it on AWS, but it's more complicated, and I don't know how to even start with S3 instances. It's hell. Don't go there unless you know what you're doing. And now something that's getting more and more praise right now, it's local models. Probably you've seen Apple keynote yesterday, and they've introduced local models inside iOS. They've also created this amazing MLX framework. It's at 15,000 stars. And this framework is optimized for Apple Silicon, for their chips, and it makes possible to run small models locally, which is insane. If you think about it, you can have a whole conversation, everything you're used to from GPT-3, let's say, you can have it inside your phone right now, which is insane, unbelievable. And there's a couple of drawbacks of using local models. First, they're big in size. It's a couple of gigabytes, which if you think about it, if you want to download an app, do you want to download 5 gigabytes, even though the app is 5 megabytes and 495 is the model? It's everybody has a different opinion. I would say, no, you don't. And they're slow because the chips in the phones, they are not as powerful, of course. So for our examples, running Llama 3B on the latest MacBook M3, we got 7 tokens per second, which is 10 times slower than what you've seen in ChatGPT, which is, it depends on what you're doing. There's also some tricks that reduce the size of the models, which is called quantization, which basically means you're compressing the model weights into smaller types. For example, if you have a 64-bit weight, you can compress it into 4 bits. But of course, you will greatly reduce the quality of the model, but also the size. So it's an experiment. We've tried it. We didn't have good results. It takes research. You have to be much smarter than we are. It takes researchers to figure out how to do this and to make it work. Apple, it seems they've done it. We will see in fall how it performs actually. So this slide is actually copied over from the previous section. Again, it's always a compromise, and you have to tailor it based on the capabilities of the problem you have. If it's simple, go for the LPU. If it's more complicated, just go for enterprise. If you don't know, if you're just starting out, go for GPT. Don't worry about the cost because you will not have users in the first place, so you won't pay anything, right? Sorry, it's a fact, sorry. So yeah, go for GPT. But then if you struggle with the costs, try and look at the other things. For example, try the LPU API. And now let's get down more into the optimizing and experiments and how to improve your models. Let me just skip this one and go back to it afterwards. The first that has been mentioned previously is precise prompting, which we've had in the previous talk. And I just wanted to clarify some things and wanted to show you a great example of good prompt. Some of you maybe know Raycast. It's a productivity tool for macOS. It doesn't matter. It's a quick, fun thing. you can, for example, create reminders. And a better way to show this is with with a video. We have a guy that invokes a command that adds it to Apple reminders. Groceries today at 6 p.m. important. Boom. And it's there. It's imported inside Apple Notes, and it has the important tag, it has the date, it has the title. So it's formatted properly, structured for the app. And how did they achieve this? I actually found their GitHub. It's public, and you can see this entire thing is the prompt. It's huge. But what can we learn from this prompt? The first thing we can learn is that constraints are so important. If you don't give constraints to your model, he will make shit up, right? You need to tell him you must return a valid parsable JSON. Any text in code should be taken in its entirety as the task title, blah blah blah. And then they have few-shot learning. Actually, I wouldn't call this few-shot. I would call it lot-shot. They have 20 examples. So they first describe the problem. They describe the object structure. They describe the rules. And then they describe examples. And right now, what they've done, they've constrained this model so much that it's basically, I would call it reliable. 99% of the time it works. If it doesn't work 1% of the time, just change the text a bit, it will work. So I think this is awesome if you have some smaller and easily definable task, like categorizing expenses, for example. You could scan invoice and scan it and paste it inside a Notion database, for example. And so I think precise prompting is very great for this. It's not good for steer, not good for working with language, which is what we found out. I'm not saying this is 100% truth, but yeah. And when last month we were in Bali, we found this one crazy guy who's into AI, and he recommended this new library called DSPY. And it's basically a Python library that finds you the best prompt for your task. It's incredibly cool. I have this very technical demo. I don't want to bore you with the details, but basically what you do is we wanted to train our grammar improver and try it in the DSPY, and you give it the task. The task is fix grammar and typing mistakes in a given sentence. Then you give it some what is considered wrong, what is considered correct. The same sentence with fixed grammar mistakes is the correct one. And then you have to define a metric function. What constitutes a good output? In our case, we had a training data set, and if a model generates something, we will compare it with the original and correct sentence, and we will count up how many words are correct. This will give you basically an accuracy of how good it is. So it's very simple, but it actually works. And you run it through, doesn't matter, and it gives you this new prompt. And as you see, we didn't give it any prompt. We just told it we need to fix grammar. And it came up with carefully review the provided English sentence, blah, blah, blah. And it actually works pretty well, pretty decent. It uses LLM under the hood to generate prompts, and then it does some form of grid search. I'm not sure I fully understand it, but it could be done for it could be used for two examples or two use cases, to finding more few-shot examples or to finding the optimal prompt. So we've tried this. It wasn't as good as the solution we have right now, but it was pretty good. So it could be something that you can experiment with and see for yourself. Maybe it would be good for the generating websites in the pipelines. Maybe you could you could look into this. But we didn't actually go with DSPY. We just tried it, and it was interesting enough to include this in this talk. And the last technique you can use is fine-tuning, which was already mentioned. And it's actually very hard to do it correctly. You need a lot of data if you want to have a chatbot that responds in a certain style. And gathering the data is not trivial, right? You have to pay someone, or you have to do it manually. Oh my God, so much work. We actually had a different project back then. It was called Glance, and we wanted to summarize articles, but not in the usual way. We wanted to extract key ideas, to enhance learning. And what we've done, we've scraped like 30 articles. We've manually gone and read them and created notes, reviewed them. We even paid some of our friends to do this for us. And we had a data set of 30 summarized articles. We gave it to the fine-tuning, it was GPT 3.5 back then. And what's funny, it actually, because some of the colleagues, they left grammar mistakes in their reviews. And we taught the model to intentionally make mistakes when it did the summaries. So, which is an interesting observation. You can teach the model to make mistakes. And it actually did a decent job at summarizing long-form articles. For example, if you know Paul Graham, it actually summarized them very nice. And again, this works if you have a pristine data set and a nicely defined problem domain. But for steer, for grammar fixing, we found Grammarly's data set, which is 20,000 rows, I think, of grammar mistakes. We've trained it on a local model with, I think it was Llama, and it didn't work as good as just plain and simple GPT-4 with a simple prompt. So fine-tuning a local model, a lot of data, a lot of work, and it's just so hard to compete, as I said in the beginning, with the enterprise models. So I'm very curious to see how it goes, where we will get in the future with local models. I'm a big fan of local models myself, because it means it's very private. You don't have to send your data to the cloud, even though Apple will tell you how friendly and secure they are. It's still their cloud. You don't know what they're doing with the data. And I think local models can be used for small tasks that are very strict and clearly defined. I think you could possibly do a local llama for categorizing your expenses, for example, or maybe not visual recognition, but the task with the reminders. I think it could be done with llama and precise prompting. So it's free for you to run indefinitely. So to wrap this up, you need to do your own experiments. You just need to try every technique, I believe, and then see, because only by trying you will actually get the notion of what works and what doesn't. You can hypothesize. I will not say it. You know what I want to say. Create your own experiments, and by doing, you will learn more than just thinking. So try everything out, really, and be aware of the problem domain and the constraints. Because if you're not, it will be much harder to actually define the prompt. If you don't know what you're solving, how can you create the prompt? You need to be absolutely sure of what you're solving, and then 90% of the time, prompting. So to wrap this up, can you use AI in a real product? Yes, you can. So I have a Q&A right now if you want, and also there's a QR code, you can scan it and find a link for Steer if you want. We will be also releasing a Steer for Windows in case anybody is interested. So you can just sign up for the waitlist, and you can also find contacts for me and Daniel if you have any questions. And yeah.